Now that we learned how to restructure our reducer a little bit here, let's dive into more state management. Let's add a new state here. Let's maybe name it results, so a new property to our state, I should say. And initially it should be an empty array. Now let's go to our counter component here. And there, I want to add a new button. So first of all, add a horizontal line with just HR, self-closing element. And I'll add a normal button here, where I'll simply say store result, like this. And this result should get added to an unordered list. This all has no styling right now, which I create below that button. Now, the idea is that when I click store result, that I simply add the current counter value to my result list here. So for that, I of course want to dispatch an action whenever this button is clicked, and then push this new result to this results array, update that array with it, and of course take the current counter as an input. Additionally, if I click one of these results, so one of these list items, I want to remove it from the array. So it should have an ID or something like that by which I can identify it, and I want to remove that list item thereafter. For this, I first of all will start here in my container component, even though I haven't worked on the reducer or anything like that, and I'll simply add two new props to map dispatch to props, because I need two new functions, basically, two new dispatch functions. One could be on store result. This should hold an anonymous function where I dispatch a JavaScript object which needs to have a type. This could be store result. And the value should be the current counter value, of course. Now, this is something I don't need to pass as a payload though, because since the counter is part of my application state, I will have access to it in my reducer anyways later. So I don't need to pass it here as payload. Of course, you could also have use cases where you want to store some result the user entered, then you would pass it as a value from your component. Here, however, it's not required. I'll then duplicate this, and I'll also set up a property which I'll name on delete result, where I want to dispatch an action, let's say with the identifier delete result. Now I have these two props, and I'll connect them in my container. Here, I'll add an onClick listener to the store result button, and I'll execute this props on store result. No parentheses as always. This is just a reference to a method and it will get executed automatically. And on the list item here, I'll also add a click listener where I'll say on delete. So this props on delete result. Now, of course, this list item doesn't have any content yet. We'll later dynamically create a list of items here. So for now, let's focus on this button here with the store result prop. When we click this button right now, I have the console open. Nothing happens. We also don't get an error. Notice this. So you can dispatch actions which you actually don't handle in the reducer. That's the first important takeaway. We are dispatching store result here because we're binding on store result, which executes this method. We're binding that to the button. So this action does get dispatched. And it does reach the reducer because we only have one single reducer in our React app, and therefore all actions make it through that reducer. But since I simply ignore it here, I have no case handling action with the type store result, I get to this line here where I return the current state. And that's it. I just returned the current state, which also means that if I change the counter through my buttons up here, and I click this, I don't reset the state, I don't return the initial state, I return the current state. So that's the first important takeaway. But let's now handle this. Let's create a new case where I say store result. And there I want to return, now I want to return what? I want to return an updated version of my state. And we should this immutable. Right now, in all the other cases, we always return a new JavaScript object where we only update the counter for the single reason that we only have the counter property there. The whole state previously was made up only by the counter property. Now we also have a results property, which is an array. And therefore right now, if we increment, decrement, add, or subtract, we basically remove that from our state because we return the updated version of the state, and it just is a JavaScript object with the updated counter, but without a results property. And unlike setState did in React, this is not merged with the old state or anything like that. This is the new state instead. So here the new state doesn't have results anymore. So actually this is not how we should update the state. Instead we should copy the old state properties and then only update the ones which need updating. And this should happen immutably. So what we don't do is, we don't set const new state equal to state and then set new state counter equals state counter plus 1 and then we return new state here. This is not how we do it. Why do we not do it like this? Because we're mutating the old state here. Instead what we do is we copy the old state. Now one way of doing this is calling object assign, passing an empty JavaScript object as the first argument and the old JavaScript object we want to copy as the second state here. Like that. Now this will basically clone the old object in an immutable way, giving us a new JavaScript object which has all the properties of the old object, but is a technically different object. And that of course is important due to the way objects and array work in JavaScript with the reference types versus primitive types. If that is unclear, definitely check this out. It is a core concept of JavaScript. Now with that we get a copy, though important, not a deep clone. So our results array still is the same object as it is here in the initial state. But here it doesn't matter. We get a copy of our state, the new state. Now there, if we change the counter, we're not doing this in the old state, but in that copied state. And we're returning that updated copied state. This will then become the new state, and it is a technically new object, and that's important. Now, you can write it like this. The shorter way is to simply return a JavaScript object, and there distribute all the properties of the old state, which you can do with the spread operator. State, like this, ... state. This simply tells JavaScript, return a JavaScript object, take all the properties and values of the state argument, which is our old state, distribute these properties with their values in this new object, and then since we define an additional property, add this property to the object, or if it already was present due to us distributing the old state, as it would be for the counter, this is part of the old state, overwrite this, but only this, leave results untouched. This is what's happening here. We're distributing the old state, we're overwriting counter, we're not touching results. So this is how we should update the state in all cases. Do it immutably. Don't touch the old state. Don't just return a new object without covering all the properties of the old state, or you're about to delete properties from your state, as we previously did. And with that in store result, we also return a JavaScript object where we distribute the old state, thus keeping the counter. But then we set results here, so this results property we want to update. We can set it equal to state results, and there we can call concat, which simply is like push, but where push manipulates the original value, concat returns a new array, which is the old array plus the argument you add to concat. So it's an immutable way of updating an array by adding an item. It returns a new array. That's the key thing here, because arrays also are reference types. If you would call push, you're touching the original results property in the original state, Even though you use the spread operator here, that doesn't prevent you from doing that. And this is not a good practice, not how you should do it. Your state management becomes unpredictable if you do it. So use concat and now push whatever you want to add to this array. For example, here we could add state counter, since we want to store a snapshot of the counter and push it to the results array. Now with that, we updated our state immutably for all cases. You learned how to update an array in your state immutably with concat by adding a new item. And now we can return that state here, or we do return it here actually, and we can use it in our counter component. There we can now bind it in map state to props to a new prop, maybe a stored results prop, which should be state results, referring to that property name you set up in the reducer, results. This has to be equal, so we're retrieving this state property. And now we can use stored results, which we can access through this props here in our render method. So here for the list item where I want to output them, I'll do it inline here with curly braces. I can say this props stored results map, and now map each stored result, which I'll store in this argument here. I'll map it to this list item. So I'll simply grab my list item and put it into my map method here to, as always, map this array of stored results into an array of JSX list items. And there, now we have our new list item where we, of course, can output stored result. And now this would be our result, but actually I want to go back to the reducer and change it a tiny bit. I don't just want to store a number, I want to create an object. And this is kind of optional here, but I want to do it because I don't just want to have my result value, and you could name this val, v, whatever you want. I also want to create an ID here. And that ID should be something unique, so I'll simply use new date, which is simply a snapshot of the date when this was added. Now I have an ID and a value, and now back in the counter component, I can use both. Stored result value, referring to that value property here in the object I push to that array, or I concat to this array to be precise. And since we have a list, we need to set a key. And I can set this key to stored result ID, that date snapshot. Now with that, if we go back to the application and I click add 10 and click store result, we see 10 here added in the middle. Let me add 10 again. Now we store 20 as the second value. So now we're storing all these values. Clicking on them doesn't do much. It also doesn't throw an error, but of course we're not handling this click listener where I want to delete the result and therefore dispatch delete result. So let's implement this in the next lecture.